Lichtblau, and this is my final project for DS4100. For my final project, I looked at a data set of drug reviews that was found on drugs.com. The data set was found from a University of California Irvine machine learning repository. You can check out that link. The data set has reviews of drugs and some metadata associated with the reviews, like what drug it was reviewing, what date the review occurred on, and just stuff like that. And the most important metadata is the final column, which states how many other users found the review useful. And so the goal of this project is to use the review and some data associated with it to try to predict how many users thought the review was useful. So they're in TSV form, tabs, but it's still very easy to just download the file. And just to show you what the data set looks like, you've got an ID, the drug name, a condition, and then you have the review, you have the rating out of 10 that it gives, 1 through 10. You have the date that it was reviewed, and the useful count, which is how many people thought it was useful. And this is the training file. Since it was found at a machine learning repository, they already had it split up into testing and training, but I'm going to bind them together because I want to do some stuff to the data before I split up and test my machine learning on it. So now it's just one data set. Next step is getting rid of NAs and blanks, which is a fairly simple cleaning method, but it removes more than 1,000 rows, which is always useful. As you can see here, 215,000 versus 213,000. So we continue to clean the data using the library string_r to make sure we can use gsub and substitute out some strings. Basically, when it got read into this data set, apostrophes got changed into this weird string of characters, and so this just changes that back. And even though we're not going to end up using the review itself, so you might say, why do I care about whether an apostrophe looks like an apostrophe or not? But we do end up using the length of the review. We're going to use that as a predictor. See, maybe if longer reviews mean more people thought it was useful, more information. So that's what we do right here. We get the length of the review and make that a column, and we also take the year from the date column, we turn that into a column. So you can see right here the year is directly from here, and the length is directly from the length of the review. So that's all the new features that we make. Next, we're going to try and visualize this data, because you always want to know what you're actually working with. So this is the ratings. You can see it's very high 10s and 9s ratings, and it's also fairly high 1s and 2s ratings. So, but in the middle there's this, which I presume to be a 5 out of 10. So it's not normal by any stretch of the imagination. It's fairly heavy on the edges, is how I would characterize this. But that looks a lot better than this, which is very right skewed, I believe is the correct way of phrasing that. There are very few reviews that had more than 500 people find it was useful. In fact, if you look down here, there's only 40 reviews that were found useful more than 500 times. It's so few that you can't even see it on this graph, but you can see the vast majority are no more than a few dozen times. You can see by this huge column right here, and the secondary column here. That's the huge majority. Unfortunately, my goal is to predict the most useful comments. So the idea being that the most useful comments are really what you want to find. You don't care so much if a comment gets 80 people to find it useful instead of 70. You're really looking for a comment to get hundreds or thousands of people to find it useful. And of course, this doesn't just apply to like drug reviews. This could apply to like political comments on Facebook or Reddit or whatever social media. It's the same idea. So the final visualization that I do is the year, and you can see there's a huge increase in for the recent years in terms of how many reviews were published in that year. So that could just be the website getting more popular, but it's just good to note. Also not normal at all. Now I'm detecting the outliers. So for useful count, again, you can see clearly the vast majority, well under 200, but it's really the outliers that I want to focus on. So I can detect the outliers and I can see them, but I don't really want to get rid of them by any stretch because that's what I'd like to predict more, if that makes any sense. So the box plot for the rest, there's not many outliers. The ratings, it can only go 1 through 10, so not that shocking that it all stays contained. The years, it can only go from 2008 to 2017, so again, not shocking at all. The length of the reviews, again, so there are a bunch of outliers, but again, I do want to keep them because I do want to see what happens at those outliers. So this might turn and bite me, but I'm going to test it out and see what happens. So the correlation analysis, the idea being that hopefully these features are correlated to what you're trying to predict, or else you're sort of not in a great place. And unfortunately, these features aren't that predictive, aren't that correlated at all with how useful a comment is going to be. So here the length is like, that's not correlated at all. That's pretty much 0. And you can see this is the graph. Obviously a bunch of overplotting here, but you can still see there's no trend at all. And for the rating and the useful count, there is a slight correlation, very slight though, but you can see, again, a bunch of overplotting, but you can see the upward trend. As you can see, the 10.0s are the ones where something ends up being very useful. So that's interesting to know, that you might want to, that the positive reviews are the ones that are thought of as more useful. And the year correlation is negative. That could just be not as many people there's not as much time to see the newer comments, so that's why less people found them useful. To prepare the data for machine learning, again, just normalizing. I'm not going to normalize the useful count because we're predicting it, so that's not necessary to normalize. But I'm going to normalize the length, and then the other two features that I'm using are actually factors, so I'm just going to change them into factors. So now we'll see that the length is now from 0 to 1. Obviously, I wouldn't z-score normalize it because none of them are normal. So now I get rid of the other features, although I will remark at the end that they are certainly useful in future studies, but for now I have no use, so I get rid of them, and now the data set just looks like this. I break up the data set into a training and testing sample, and this is just the training numbers. Let's ignore. So this is the training data, this is the testing data. See that training has 3 times as many rows. So next I did my machine learning models and see if anything fits. So it looked good. All the stuff was, all the categories and were significant, which is usually good, but I did not have nearly enough features nor enough of a correlation between them to predict anything usefully. And you can see that the mean error for each prediction is 20 when the standard deviation is 37, so more than a half of a standard deviation off, which is just not ideal at all. And you can see this is just the prediction and errors. And then I try a logistic model, but the same exact thing happens. So literally the exact same errors the mean of the error and the same testing data comes back. So I try to get rid of one of the features and see what happens. To get rid of length with the logistic model and see if that helps, hurts, and it very slightly hurts in terms of AIC. The AIC is slightly bigger, but the mean of the error is exactly the same. So even though they didn't return what I wanted, the predictions are not great, there's still a lot of lessons to learn. Number one, garbage in, garbage out, fairly simple. Don't have good correlations, not going to get a good prediction. And the second is outliers are extremely hard to predict. And there's a few other ways I could have gone and tried to predict things. I could have used sentiment R, but the packages that I needed weren't able to download on my computer for some reason. And I could also try the idea of using the dates, not just the years, but the dates, and maybe try and make a time series. So that's some ideas to look forward to in the future.